Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Primary alcohols have the OH group on a carbon attached to only one other carbon, i.e., CH2O. We need to find all structural isomers of C5H12O that are primary alcohols, including stereoisomers, enantiomers due to chiral centers. Moving on to the next step. Find all primary alcohol structural isomers with formula C5H12O. The carbon skeleton must have 5 carbons with OH on a terminal or primary carbon. Structure 1 in pentanol, 1 pentanol. CH3, CH2, 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 CH2O. No chiral center. Count 1 structure, no stereoisomers. Structure 2, 2-methyl, 1-butanol. CH3, CH, CH2CH3, CH2O. The C2 carbon bears CH3, CH2CH3, CH2O, H, 4 different groups, so it is a chiral center. Count 2 stereoisomers, R and S enantiomers. Structure 3, 3-methyl, 1-butanol. CH3 to CH, CH2, CH2O. No chiral center. Count 1 structure. Structure 4, 2,2-dimethyl, 1-propanol, neopentyl alcohol. CH3, 3C, CH2O. No chiral center. Count 1 structure. And for the final step. Total count. 1 in pentanol plus 2, 2-methyl, 1-butanol with R and S plus 1, 3-methyl, 1-butanol plus 1, 2, 2-dimethyl, 1-propanol is equal to 5 primary alcohols including stereoisomers. Why other options fail? A. 2 grossly undercounts structural isomers. B. 3 counts only structural isomers without stereoisomers. C. 4 misses one stereoisomer pair or one structural isomer. D. 5 correctly accounts for all 4 structural isomers plus the pair of enantiomers from 2-methyl 1-butanol. Therefore, the correct answer is D. Therefore, the correct answer is option D.